So, welcome everyone to our webinar on scientific problem solving. I'm Ahmed Radwan, your guide for this session. As we get started, please share in the chat where are you joining from. It's always great to see the global reach of the continuous improvement professionals and enthusiasts. So I'm joining from Australia, from Melbourne. So let me know where are you joining from in the chat. California, nice. Germany, Sweden, Algeria, Canada, Turkey, Serbia, Turkey again, United States, Arkansas, Portugal, Netherlands, Poland, Brisbane, Australia. Welcome. Lithuania, Romania. That's really nice. It's almost around the globe from east to west. So today we will explore how structured methods like A3 thinking and the 7 basic quality tools can transform how you tackle problems like a scientist. So here, what we are going to cover today, so we will start with what makes problem solving scientific. Then we will dive into A3 thinking, the PDCA cycle, and the 7 basic quality tools. Finally, stick around for a Q&A and special year-end offer that's exclusive to the webinar participants, tailored for the continuous improvement professionals that we will reveal towards the end. You wouldn't want to miss this exciting opportunity to elevate your skills and impact. Also, in today's session, we're going to have a nice small competition towards the end, and the top 3 winners will have the opportunity. So we will reward them with this with a certificate of their distinction in scientific problem solving, and at the same time we will give them access to all of our online academy courses for a month. So let's talk about scientific problem solving first. So why problem solving has to be scientific? So scientific problem solving is about identifying the problem that you're trying to solve and its context. So this requires you to identify the current condition and the target condition for the problem that you're trying to solve, analyzing the problem or the opportunity based on facts, building a solution based on a solid ground of facts and proper analysis, then testing out those solutions and checking if they produce the required target condition, and therefore maintaining and standardizing the outcome. So of all of this exercise, it's not just about filling out a piece of paper or using the tools that we all know of. So if I may ask you, have you encountered a situation where you later realized that you were solving the problem in an ad hoc manner or non-scientific or non-methodological manner? I'd like to see your answers to this in a yes or no in the chat. So have you ever encountered a situation where you later realized that you were solving the problem in an ad hoc manner? I can say myself, yes. So thinking scientifically is not something that you can learn like just overnight, but it requires continuous practice. And this continuous practice will necessarily mean that you will make mistakes, which is 100% okay. That's really nice. So I can see, yes, but not lately. And yes, and yes, and yes. So we are in agreement in this arena. Um, so A3 thinking, um, which is a key topic of our discussion today, is developed by Toyota. And it's a mindset and a tool that helps you document problem and solution on a single sheet of paper of what is known as the A3 size. Um, and it's about clarity, collaboration, and continuous improvement. So basically, it's a principle, it's an approach to problem solving, um, um, and you use this kind of a template or a, a document of this size to guide you to problem solving. So integrating the A3 into team activities help companies stop avoiding problems and viewing them as appropriate for learning, as appropriate opportunities for learning and improvement. And the A3 promotes a scientific approach that encourages individuals to observe, present data, propose solutions, and adjust based on the results. So in a scientific way again. So it serves as both problem-solving tool and a structured process for developing skills for future problem solvers. And as we did mention here, a scientific method that includes observe, use of data, proposing countermeasures, checking and adjusting, and this are all elements included in the A3 methodology. What does this remind you of? Think of an improvement approach that is comprised of 4 letters. So what is the, let me know in the chat, what is the approach that is comprised of 4 letters that helps us think scientifically in problem solving and continuous improvement? That's right. That's PDCA. So how A3 is related to PDCA? So the plan PDCA, that stands for Plan, Do, Check, and Act, is a cornerstone of A3 thinking. It's like a scientific way for problem solving. You plan your hypothesis. As a scientist, you test the hypothesis, you try it, and then you evaluate the result and then adjust. This iterative cycle ensures that learning never stops. So this is like the essence of the PDCA. So if we look into the content of the A3, a typical content of the A3, it includes the problem background, the current condition, the root cause analysis, countermeasures, and follow-up actions. So background, current condition, goals and targets, analyzing the problem, propose countermeasures, planning, also for doing, and follow-up, which is check and act. So you can see the background is planning, the current condition is planning, goals and targets are planning, analyzing is planning, proposing countermeasures, then we start to do, and then planning for executing those countermeasures is also part of doing, and then finally you check and act. So in this precise format, is not like something rigid that you have to follow verbatim, but it's a starting point, or it's a guidance to make yourself familiar with these concepts. So it's worth highlighting that it's not the format of the report that matters, but the underlying thinking that leads to you to a cycle of BDCA. The 7 tools that can help in identifying the the current condition, goals and targets, analysis, um, and many other aspects of E3. We will discuss them together later today, and we will know which one of these 7 tools can be helpful in each part of our A3. By the way, I'll be providing you with this template after the webinar. So this is an example of actually filled an A3, and so it starts with like a background, the current condition, analysis, and the goals, the countermeasures, future state map, and so on and so forth. So it helps you to guide your thinking while trying to solve any problem in a scientific, in a structured way. And this is another A3. So as you can see, it's not like just a rigid one format, but it's always a good idea to start somewhere with any template, and then from this you learn how to adapt it to your actual situation. So if we hear this quote from John Schock, so John Schock was one of the early popularizers of lean, and he used to work for Toyota for 12 years. So he says the A3 reports should become a standardized form for creating an organization of scientists who continually improve operations and results through constant learning from work at hand. So basically, you're trying to make use of the problems that you see to create an army of scientists inside your organization by practicing scientific problem solving using the A3 methodology. Now we're going to talk about the 7 basic quality tools. So the Japanese professor Kaoru Ishikawa, who also developed the fishbone diagram that we all know of, or most of us know of, and played a key role in the development of the 7 quality tools and the concept of the quality circles during the quality movement in Japan in the 1960s. And his motivation for developing those tools in his book Guide to Quality Control, that quality control was often too complicated for many workers and companies, and he helped companies to use these straightforward tools that were accessible for everyone to learn and implement. I guess myself and many of you could see, like for example, workers will be can learn many of those tools very quickly and start using them for example, like fishbone diagram, check sheets, and some other tools. They can be learned very quickly by workers to help them, to guide them to start thinking in a scientific way. So the 7 basic quality tools include the histogram, the cause and the effect diagram, the check sheets, Pareto diagrams, the graphs, control charts, and the scatter diagram. Each tool has its own unique purpose, and we should not, like I want to stress this enough, you should not push these tools into the problem that you're trying to solve. We need to think scientifically, not just use the tools that we have, but you pull the tools as you need them to your specific problem. So, for example, you can use the histogram to assess the distribution of product weight in the manufacturing process. And for example, if you want to identify the major causes of delays in project management, for example, you can use the Pareto diagram. We're going to discuss each of those tools briefly, but we will also be focusing a little bit more on the histogram and the Pareto diagram. If I may ask you, which of these tools did you do you often use? So we have the, let me go back one slide. I can, yeah. So we have the histogram, we have the fishbone diagram, the check sheets, Pareto diagram, the graphs, the control charts, and the scatter diagram. So I can see graphs, Ishikawa, all, and it depends on the situation. Perfect. Yeah, Pareto all the time. Typically, histograms and Pareto. Yeah, all but scatter diagram. That's really nice. And they're like the right answer is, or all of these answers are right, so you can use them according to your the actual situation. So let's start with the histograms. So histograms are perfect for visualizing data distributions. They help identify patterns and variations in the process. For instance, you can use a histogram to assess the product weight in manufacturing or product thickness, for example. And as you become more aware of your performance using the histogram, you can later on produce a consistent quality based on such insights coming from the histogram. So, for example, if we see like this amount of data about a product thickness, these are not easy to get insights from. So we need to use, for example, in this instance, the histogram to understand how are we performing. So to prepare a histogram, you need to follow 4 key steps. So first you need to calculate the range, identify number of classes, calculate classes and frequency in each class, and drawing the histogram. Of course, we're not going to go through all of these all of the details included into building a histogram, but basically you end up with something like this, and from this you can agree with me that by having a histogram like this, you are in a better position to understand the performance of your products and processes, right? So we can know confidently, very quickly, that like the thickness, the most of the like the most prominent thickness coming of this process is 3.47, between 3.47 and 3.51. That's an easy thing to derive from the diagram, and then you can see like we have also to the far right and to the far left many other readings. And the story doesn't end with just drawing a histogram, but we need to read and use the histogram. There are many methods to do this. The first is the shape of the distribution. So by understanding many aspects related to how the histogram should look like. So for example, what are the most common values? How great is the dispersion? Is the distribution symmetrical? Is it skewed? Is there only one peak or many peaks, and so on and so forth? So basically, from this distribution, you can understand the characteristic of your product or of your process. Another way to do this is to compare the histogram to specification limits. For example, you can determine from this histogram that after knowing, like after putting your specification limits, like for example here we know like the lower specification limit is 3.28 and the higher specification limit is, or the upper specification limit is 3.6, and from this you can know that 3% out of the 3% of our our readings are out of specification limit, the average is 3.48, target is 3.44, and the dispersion is too high, and the process is not centered. A second tool in the 7 QC tools, or the basic quality tools, is the cause and effect diagram. I'm a big fan of it because it's easy and simple and easy to for literally or virtually anyone to learn it quickly and use it. Of course, it requires also practice to master it. But also, as known as the cause and effect diagram, is also known as the fishbone or Ishikawa diagram. Now we know why it's called Ishikawa diagram, referring to Mr. Kaoru Ishikawa. This tool helps identifying root causes by categorizing potential factors. So instead of just jumping to causes randomly, you identify the potential factors such as, for example, work methods, material, measurement, environment, and so on and so forth. It's invaluable for understanding why issues occur and where to focus your effort. Did fishbone diagram help you with problem solving before? Let me see the responses in the chat. Did you find it helpful in your work, personal or professional? Yes, I do agree with you. And the key part why I like it, along with others, is how it is easy to explain, and at the same time, it helps you from jumping into helps you to avoid jumping into conclusions without understanding the other aspects or the different dimensions of the problem on hand. So instead of focusing, for example, just on the workers and why they are not doing what they are supposed to do, you also consider the other aspects such as the environment, equipment, work methods, and so on and so forth. So we had a complete webinar on the fishbone before, and also the 5 whys. We are happy to share with you by email later, along with the template that I mentioned previously, that discusses more of the how to do the fishbone, why to do the fishbone, and the key benefits of it. The third tool is check sheets, and basically this is a perfect tool to use in the shop floor. So sometimes instead of like collecting the data and then preparing a histogram, just for the sake of this example. So when preparing a histogram, you need to collect a great deal of data first, make a frequency distribution table from this data, maybe in a computer system, and then you know how are you performing. But this sometimes it's an unnecessary double task, and it can be easier in many applications to use check sheets like this one, for example, to record data and analyze it at the same time. So you have like a template that the operators can fill directly if you're collecting the data manually. And if you look at this graph, just after you record the tallies, you can understand the distribution of the data without further calculations or equations or something like this. And this helps a lot to get better insight or quick insight on how you are performing, and also the operator themselves can understand their performance and act accordingly according to the shape or the performance of their process, coming from the insights of the of their check sheets. Another tool that we're going to discuss today is the Pareto diagrams. So it's like if you can see here, like we have like the number of defects for each kind of defect, and this is the percentage of these defects, and then this is the this distribution of the defects, and this can be useful, but at the same time, if you use a graphical format to show the distribution, or use a diagram to show how every cause of these contribute to the problem, that can help you much more to understand your current performance. So it's much easier to see which defects are most important with a bar graph than by just using a table numbers only. According to this graph, we should tackle, like, for example, caulking first, and then because it forms the tallest bar, the next most significant defect is the second, is the connecting, and then capping, and so on and so forth. The Pareto diagram mostly follows the 80-20 rule, and therefore you can derive from it what are the key causes that we need to focus on more in order to solve most of our problems. So it helps you to define the priorities for improvement and building common understanding of the priorities, and it helps you to define the weights of causes and to track results. So for example, for this situation, if we need to tackle 75% of our problems, we should, or of our defects, we should focus on just 2 reasons out of 5, which are connecting and caulking. And this is how can you identify or develop a Pareto diagram. So you identify the classification, and then you identify the time range, some of the classification for each cause, and calculate the percentage, draw the bar chart from the highest to lowest, and then draw the line chart over the bar chart using the secondary axis by the cumulative percentage of the contribution of each of those causes. And then you can use the percentage to identify the target classification. Let me show you one thing which can be useful and helpful to use. So if you can see with me here this this diagram, which is built on an Excel template. So for example, you have here your Pareto diagram, and if I want to focus, for example, as we said, from on the 70% of the causes, you go like this, and then as you hit the line, then you need to go down and see what are the causes to the left of that line that are. This will give you the answer which causes you need to focus on more. And as you change the data here, for example, so if we say like this becomes only 5, and this becomes like 300. This diagram can be dynamically reporting to you what is the what are the top causes that you need to focus on, and this is like part of the templates that we use in our coaching programs that you can even customize it later for your own use. Today I will be sharing with you this A3 template that you can that you can use in your own work. So I will share this template, the A3 template, with you after our session. Back to our presentation. So check the time. Good. So and back to our 7 tools. So now we have the graphs, and the graphs basically are as identified by Ishikawa. There are 3 types of graphs that you can use. So first is the line graph, and the second is the bar charts, and the histograms, for example, are an example, and also the Pareto diagrams are examples of a bar chart. And finally, the circle graphs, as Ishikawa calls it, or pie charts as we know it, and it helps you to identify the a percentage contribution for different aspects or different causes. And as you could see, like here in the other template, it's always helpful to make use of the templates to help you do faster calculation. So the 7 quality tools also include the control charts, and the control charts helps you to monitor process stability over time, and they are essential for identifying variations and maintaining consistency. By using these, you can ensure that your processes remain within acceptable limits. Do you use control charts now, or did you use it before in your work? Let me know in the chat. Good. Nice. Good, good. That's really nice. Okay. And the last of the 7 tools is the scatter diagrams. And the with a scatter diagram, there are you have two kinds of data that are indexed and then plotted on an ordinary graph, like a dot plot. And from this chart, for example, you can see here that the moisture content is greater as the elongation is larger. So you can see like there is a positive relationship between those two factors. And of course, drawing a histogram is drawing a scatter diagram is not the end of the story, but the correct reading of a scatter diagram must lead to proper action. So you need to be careful on how the correlation between two variables is being interpreted. So sometimes you will have a positive correlation, negative correlation, or no correlation at all. So how can we make use of those tools in our A3? So this table outlines the typical sections of an A3 report. As I said before, like there is no like fixed rigid A3 template, but what I will share with you is a starting point, which is derived also from the Lean Enterprise Institute template. But if we see these sections as like the typical sections, these are the suitable tools that you can use in each of the sections. And as you can see, we can see the check sheets, the histogram, the charts, control charts, the fishbone diagram, and so on and so forth. So in order to like implement A3 and use the scientific problem solving tools, it's I will share with you like some tips on how to get started. So don't stress about whether you use a pen, pencil, or a computer program. Just begin whatever you feel comfortable with. Start the process and learn from the experience, and ensure you have a sponsor for each A3. Align each A3 with the organizational objective. There is a methodology that's known for this, which is the Haushinkanri. Educate the stakeholders that are involved. Formalize the A3 as a standard process for problem solving. And if you have already a well-established problem solving methodology within your systems in your organization, it's a good idea to see how they will fit together and integrate them together. You don't need just to demolish what you have, but use what you have. And always, as long as it is in alignment with the scientific principles, and always ask yourself, what is the problem that we're trying to solve? Don't just go and try to solve problems without understanding the background, the current condition, and what are we trying to solve, and what is the target condition.